What would you do if you were nearly 200,000 miles from Earth, trapped inside a dying spacecraft with almost no oxygen, almost no power, and almost no chance of making it home? There were no rescue ships, no emergency landing, no second chances. Just three ordinary men floating through the endless darkness of space, knowing that one wrong decision could turn them into humanity's first permanent graveyard beyond Earth. Before we begin, answer this in the comments. If Mission Control told you there was almost no chance of survival, would you keep fighting or would you accept your fate? Because on April 13, 1970, three American astronauts were forced to answer that exact question, and their answer became one of the greatest survival stories ever told. Space has always looked peaceful from Earth. Every night, millions of people looked upward and saw thousands of tiny stars shining quietly across the sky. Children dreamed of walking on the moon. Scientists dreamed of exploring new worlds. America dreamed of proving that nothing was impossible. But the silence of space was deceptive. Beyond Earth's atmosphere, there was no air, no sound, no warmth, no forgiveness. Space was not beautiful. Space was indifferent. One tiny mistake could destroy years of preparation in less than a second. By 1970, NASA had already achieved what humanity once believed impossible. Only 9 months earlier, Apollo 11 had carried Neil Armstrong and Buzz Aldrin onto the surface of the moon, while millions watched history unfold on live television. America celebrated. The impossible had become reality. The United States had won the greatest technological race in history. Many people believed the hardest part was over. They couldn't have been more wrong. Landing on the moon was only half the battle. Getting home was always the real mission. NASA understood something the public rarely thought about. Every Apollo spacecraft was essentially a tiny island of life drifting through one of the deadliest environments imaginable. The astronauts carried every breath they would ever take, every drop of drinking water, every watt of electricity, every ounce of fuel. Every system depended on another. If one failed, others could fail with it. There were no rescue spacecraft floating between Earth and the Moon, no emergency exits. If disaster struck hundreds of thousands of miles from Earth, the crew would be completely alone. Yet every mission continued pushing farther into the unknown, because exploration had always demanded courage. Long before astronauts crossed the heavens, sailors crossed dangerous oceans, explorers crossed frozen continents, pilots crossed impossible skies. Now a new generation crossed space itself, and every journey carried enormous risks. NASA accepted those risks, so did every astronaut. None of them expected an easy mission, but all of them believed preparation could overcome almost anything. Years of training transformed ordinary military pilots into some of the most capable problem solvers on Earth. They trained underwater, inside spinning simulators, inside vacuum chambers, inside mock spacecraft that reproduced nearly every emergency engineers could imagine: fire, electrical failure, computer malfunction, navigation errors, power loss, communication blackouts. Every disaster was rehearsed again and again. The philosophy was simple: train until panic disappears. Train until every movement becomes instinct. Train until impossible situations become solvable problems. That philosophy had saved lives before. NASA hoped it would never need to save another. The mission, officially known as Apollo 13, was never supposed to become famous. In fact, it was expected to become one of NASA's most routine lunar missions. The headlines had already faded after Apollo 11. Apollo 12 had also landed successfully. To many Americans, moon landings were beginning to feel almost ordinary. Television networks planned less coverage, newspapers devoted fewer front pages, public excitement slowly declined. But inside NASA, no mission was ever ordinary. Every launch remained a carefully balanced masterpiece of engineering. More than 5 million individual parts worked together inside the towering Saturn V rocket. Each bolt, each valve, each electrical wire, each computer, each oxygen tank had only one job: work perfectly. Because perfection wasn't optional. Perfection meant survival. Failure meant death. As launch day approached, 3 men prepared to climb aboard one of the most powerful machines humanity had ever built. Commander James A. Lovell, Jr., Command Module Pilot John Swigert, Jr., Lunar Module Pilot Fred Haise. Each of them had followed a different path toward this extraordinary moment. Yet all 3 shared one belief: America's future reached beyond Earth. Jim Lovell was no stranger to danger. He had already flown into space 3 times. He had orbited Earth. He had circled the moon aboard Apollo 8 during humanity's first journey around another world. Now, Apollo 13 offered something he had never achieved: walking on the moon itself. After years of preparation, this would likely become the greatest moment of his life. Fred Haise represented a newer generation of astronauts, calm, highly skilled, relentlessly determined. Apollo 13 would become his first journey into space. Years of dreaming had finally become reality. Then there was Jack Swigert. Although history remembers him as one of Apollo 13's heroes, he almost wasn't aboard the spacecraft at all. Just days before launch, NASA faced an unexpected medical concern involving another astronaut assigned to the mission. Doctors feared possible exposure to German rubles. The decision had to be made immediately. Jack Swigert was called as the replacement. Few people could have imagined how significant that last-minute change would become. History sometimes turns on moments so small they almost seem invisible. A phone call, a medical decision, one replacement, one delay, one switch, and suddenly the course of history changes forever. None of the 3 astronauts knew what lay ahead. Neither did the thousands of engineers working around the clock inside NASA. They believed they had prepared for every possible emergency, almost every one. But history has a cruel habit of inventing problems nobody expected. Meanwhile, across America, families watched another Apollo launch with quiet confidence. The moon no longer felt unreachable. The impossible had become familiar. Children carried toy rockets. Schools taught space science. Television celebrated astronauts as national heroes. The future looked limitless. Nobody watching that spring could imagine they were about to witness NASA's darkest and most inspiring survival story. Thousands gathered near Florida's Atlantic coast. Others watched from rooftops. Millions prepared to watch on television. Towering above Launch Complex 39A stood a machine unlike anything ever built, the Saturn V. Standing 363 feet tall, weighing over 6 million pounds, containing enough power to shake the ground for miles. It wasn't merely a rocket, it was humanity's declaration that no frontier was beyond reach. As sunrise illuminated Cape Kennedy on April 11, 1970, technicians completed their final inspections. Controllers filled computer screens with streams of numbers. Weather officers studied every cloud. Flight directors reviewed every checklist one final time. Inside the spacecraft, the crew quietly prepared themselves. Each movement reflected years of discipline. Each heartbeat carried decades of ambition. Outside, the world waited. Inside, 3 men prepared to leave their planet behind. None of them knew that within just a few days, the moon would no longer be their destination. Survival would be.
On the morning of April 11, 1970, the air around Cape Kennedy vibrated with anticipation. Towering over the launch pad stood the Saturn V, a colossal giant built from steel, fuel, mathematics, and human ambition. For years, thousands of engineers had poured their lives into this machine. It represented the very best America could build. More than 400,000 people had contributed to the Apollo program. Millions more believed in it, and today, everything depended on a launch lasting less than 12 minutes. Inside the White Room near the top of the rocket, Commander Jim Lovell paused for a brief moment before climbing into the spacecraft. He had spent years preparing for this mission, countless simulations, thousands of hours inside cramped capsules, hundreds of emergency drills. Now, every lesson would finally be tested. Fred Haise followed close behind. Despite his calm expression, excitement surged through him. This was his first journey beyond Earth's atmosphere. Few people ever had the privilege to see the entire planet from space. He was about to become one of them. Jack Swigert entered last. Only days earlier, he had not expected to fly at all. Now he occupied one of the most important seats in the spacecraft. History often changes without warning. Sometimes it changes because of a simple phone call. The astronauts settled into their couches. Technicians connected dozens of cables. Medical sensors monitored every heartbeat. The hatch closed. Bolts locked into place. For the next several days, the spacecraft would become their entire universe. Outside, thousands of spectators stretched across nearby beaches and highways. Parents lifted children onto their shoulders. Photographers adjusted enormous cameras. Television crews counted the final minutes. Across America, millions gathered around television sets. To many viewers, another moon mission no longer seemed extraordinary. Apollo 11 had already made history. Apollo 12 had proved it wasn't luck. Apollo 13 appeared to be destined to become another successful mission. No one imagined they were watching the beginning of a fight for survival. Inside Mission Control in Houston, Texas, the atmosphere was remarkably calm. Rows of engineers sat before glowing computer displays. Each person specialized in one critical system: electrical power, navigation, communications, guidance, life support, propulsion. Each person understood one truth: one mistake could cost 3 lives. Flight Director Gene Kranz walked quietly through the room. His crisp white vest had become famous throughout NASA, but his reputation came from something far more important: discipline, preparation, absolute focus. Kranz believed failure was never acceptable. Every controller understood his expectations. Know your system, trust your training, never panic. At 1:13 p.m. Eastern Time, the countdown entered its final moments. 10. Every conversation stopped. 9. The astronauts stared at their instruments. 8. Millions held their breath. 7. Massive engines prepared to ignite. 6. The rocket trembled. 5. Clouds of steam surrounded the launch pad. 4. The ground itself seemed to vibrate. 3. 3 men prepared to leave Earth behind. 2. An ocean of fuel erupted beneath them. 1. Ignition. The 5 gigantic F-1 engines unleashed nearly 7.5 million pounds of thrust. The ground shook violently. Windows rattled miles away. A brilliant column of fire burst beneath the Saturn V. Slowly, almost reluctantly, the enormous rocket began climbing into the Florida sky. Cheers exploded across the beaches. People applauded. Some cried. Others simply stood in silence. It was impossible not to feel inspired. The Saturn V accelerated higher every second. Within moments, it was traveling faster than the speed of sound, then twice the speed of sound. The first stage separated perfectly. The second stage ignited flawlessly. Every number arriving inside Mission Control looked exactly as engineers expected. The mission was proceeding beautifully. 12 minutes after launch, Apollo 13 reached Earth orbit. The first major milestone was complete. But reaching orbit had never been the destination. The moon still waited nearly 240,000 miles away. After one orbit around Earth, Mission Control gave the command. It was time for translunar injection.
The third stage engine ignited once again. For nearly 6 minutes, it accelerated the spacecraft faster and faster until Earth's gravity could no longer hold it. Apollo 13 was leaving home. There was no turning back. Soon afterward, one of the most delicate maneuvers of the mission began. The command module, named Odyssey, separated from the rocket. Jack Swigert carefully rotated the spacecraft. Facing him floated the lunar module, Aquarius, the tiny spacecraft that would eventually carry Lovell and Haise to the moon. Using precise thruster bursts, Swigert guided Odyssey towards Aquarius. The docking required absolute precision. A mistake could end the mission immediately. The spacecraft drifted closer. Only inches separated them. Then, a solid metallic click echoed through the cabin. Docking complete. Another perfect maneuver. The combined spacecraft slowly pulled away from the final rocket stage. Their journey toward the moon had officially begun. Outside the windows, Earth grew smaller every hour. At first, entire continents remained visible. Then, only swirling white clouds. Eventually, the planet became a beautiful blue marble suspended in endless darkness. No photograph could truly prepare anyone for that sight. Jim Lovell stared quietly through the window. Later, he would describe Earth as breathtakingly fragile. Every human being, every city, every ocean, every war, every dream contained within one tiny blue world. From space, borders disappeared, conflict disappeared. Only home remained. Life aboard Apollo 13 quickly settled into routine. The astronauts performed navigation checks, conducted scientific experiments, recorded television broadcasts, shared jokes with mission control. Everything appeared wonderfully ordinary. One television transmission showed the spacecraft's interior. Jim Lovell floated effortlessly through the cabin, demonstrating life in zero gravity. Fred Haise laughed as objects drifted around him. Jack Swigert explained various onboard systems. The astronauts smiled. Mission Control smiled. Viewers watching television smiled. Ironically, few people tuned in. The excitement surrounding moon missions had faded dramatically. Several television networks interrupted the live broadcast. Some returned to regular programming. Others chose different news stories. One producer reportedly believed viewers had become bored with space travel. The greatest survival story in NASA history was quietly unfolding before an audience that didn't yet realize history was about to change. Everything looked normal. Too normal. The spacecraft continued its graceful journey through deep space. Every system reported healthy. Every oxygen tank functioned perfectly. Every electrical circuit performed exactly as designed. The crew enjoyed meals, completed routine maintenance, talked casually with mission control. No alarms, no warnings, no signs of danger. But hidden deep inside one oxygen tank, a flaw had been waiting for years. Not days, not weeks, years. It had survived inspections, manufacturing, testing, transportation, installation, every safety check. Invisible, patient, silent. And soon, that tiny hidden flaw would unleash a chain of events unlike anything NASA had ever faced. The moon still seemed within reach. The astronauts believed they were halfway towards making history. They had no idea history was already racing towards them.
The silence of deep space is unlike anything on Earth. There is no wind, no birds, no distant traffic, no waves, nothing. Only endless darkness stretching billions of miles in every direction. Inside Apollo 13, however, life continued with remarkable normality. The crew woke according to schedule. They exercised to reduce muscle loss, prepared meals that floated weightlessly through the cabin, completed navigation updates, checked environmental systems, recorded engineering data. Every task followed a carefully planned timeline that NASA had spent years perfecting. The spacecraft itself had become a tiny island of life. Every breath the astronauts inhaled came from carefully controlled oxygen tanks. Every light inside the cabin depended on electricity produced by hydrogen fuel cells. Those fuel cells created not only electrical power, but drinking water as well. Power, water, oxygen, each depended upon the other. It was a beautifully engineered system, but it also meant that if one part failed, others could fail with it. Jim Lovell floated toward one of the windows. Outside, Earth had become astonishingly small. It was now nothing more than a glowing blue sphere suspended in endless blackness. The moon, meanwhile, grew brighter every hour. Its gray surface slowly expanded against the darkness. For the first time in his career, Lovell wasn't simply traveling through space. He was returning to a place he had already visited. During Apollo 8, he had become one of the first humans ever to orbit the moon. But this mission was different. This time, he expected to land. He had imagined that moment for years. The first footprint, the first sample, the first step onto another world. He had earned it. Fred Haise often caught himself staring through the windows. No simulator, no photograph, no documentary could prepare anyone for the overwhelming beauty of space. Sunlight appeared almost painfully bright. The stars never twinkled. Earth glowed like a living jewel. It was breathtaking and strangely peaceful. Jack Swigert remained focused on Odyssey's complex systems. As command module pilot, the spacecraft itself was his responsibility. Thousands of switches, hundreds of gauges, endless checklists. Everything looked perfect. Mission Control agreed. Back in Houston, engineers watched streams of telemetry flowing across computer screens. Temperatures? Normal. Voltages? Normal. Fuel cells? Normal. Oxygen pressure? Normal. Every number inspired confidence. Flight Director Gene Kranz quietly reviewed reports from each controller. Guido, the guidance is good. Ecom, the electrical systems are good. Fido, the trajectory is good. One by one, every station confirmed exactly what NASA hoped to hear. Apollo 13 was healthy. Perhaps too healthy. Routine has a dangerous habit. The longer everything goes perfectly, the easier it becomes to believe nothing can go wrong. NASA knew better. That was why every single day included maintenance procedures, small housekeeping tasks, equipment inspections, systems checks. One of those routine procedures involved stirring the oxygen tanks. Inside the spacecraft, 2 large tanks stored liquid oxygen. Because oxygen naturally separated into layers during weightlessness, NASA occasionally instructed astronauts to activate small internal fans. The process mixed the contents together. It had been done before, many times. It was completely ordinary, completely safe. Or so everyone believed. Far below, on Earth, families followed the mission whenever they could. Jim Lovell's wife, Marilyn, understood spaceflight better than almost anyone. She had lived through previous missions. She understood the dangers. Yet she also trusted NASA. If anyone could protect astronauts, it was the thousands of brilliant engineers working around the clock. Across America, interest in Apollo 13 remained surprisingly low. Television ratings disappointed broadcasters. Many newspapers dedicated only small sections to the mission. People had grown accustomed to moon flights. Success had become expected. Perhaps that was inevitable. History often forgets how extraordinary repeated achievements truly are. Crossing an ocean by airplane no longer feels miraculous. Neither did traveling toward the moon. But space never became ordinary. It only appeared that way. Every second remained unforgiving. One failed valve could destroy everything. One damaged wire could end an entire mission. One overlooked detail could change history forever. Hidden deep inside oxygen tank number 2, an invisible danger waited. Years earlier, long before Apollo 13 ever existed, the tank had accidentally been dropped during maintenance. Technicians inspected it, believed it remained usable, reinstalled it. Later, another seemingly harmless mistake occurred during ground testing. The tank had been heated far longer than engineers intended. Unknown to everyone involved, protective insulation surrounding internal electrical wiring had been damaged. Nothing appeared unusual afterwards. Every inspection passed. Every measurement looked acceptable. The tank continued through NASA's system. Eventually, it found its way into Apollo 13. No engineer intended this. No technician ignored safety. No astronaut made a mistake. Sometimes, history changes because several tiny imperfections quietly align, each harmless alone, catastrophic together. None of the astronauts knew that an invisible electrical wire inside one oxygen tank had become dangerously exposed. None of Mission Control knew either. The spacecraft continued racing toward the moon at nearly 2,000 miles per hour. Every passing minute carried them farther from Earth, farther from help, farther from rescue. If disaster happened now, no spacecraft on Earth could reach them. The astronauts themselves represented humanity's most distant explorers, completely alone, completely dependent on a machine no larger than a family car. On the evening of April 13, 1970, the crew finished another television broadcast. Jim Lovell joked with Mission Control. Fred Haise smiled as he demonstrated life inside the spacecraft. Jack Swigert carefully organized equipment for the next day's work. Nothing seemed unusual. The broadcast ended. One NASA employee reportedly remarked that everything looked almost boring, exactly the way engineers preferred. Several controllers relaxed slightly. Another routine evening. Another routine systems check. Then, a familiar instruction arrived from Mission Control. Simple, ordinary, completely routine. Houston, we'd like you to stir the cryogenic tanks. It was a command Apollo astronauts had received many times before. Nobody inside Mission Control hesitated. Nobody inside Apollo 13 questioned it. Why would they? The procedure had become standard, safe, predictable. Jack Swigert reached toward the panel. His hand hovered over the switch. One small movement, one routine action, one electrical command sent into oxygen tank number 2. At 9:08 p.m. Houston time, he flipped the switch. And in less than 2 seconds, the entire mission changed forever.
Jack Swigert's fingers barely left the switch. For a brief moment, nothing happened. The spacecraft continued gliding silently through the darkness nearly 200,000 miles from Earth. Jim Lovell floated toward another checklist. Fred Haise was organizing equipment for the next day's preparations. Mission Control watched their computer screens without concern. Everything appeared exactly as expected. Then, a violent bang echoed through the spacecraft. It wasn't loud like an explosion on Earth. In the vacuum of space, sound could not travel outside the spacecraft. But inside, the astronauts felt it. A deep metallic thud ripped through Odyssey. The entire spacecraft shuddered violently. The cabin shook. Loose equipment drifted wildly through the air. The astronauts looked at each other in stunned silence. For a split second, nobody spoke. Jim Lovell instinctively grabbed a handhold. What the hell was that? Before anyone could answer, warning lights exploded across the instrument panel. One alarm, then another, then another. The calm, familiar cockpit transformed into a flashing sea of red lights. Master alarm, main bus warning, fuel cell warning, electrical warning, pressure warning. The spacecraft had never looked like this before. Jack Swigert stared at the gauges. One number immediately caught his attention. Voltage dropping rapidly. Another gauge, oxygen pressure, falling. Impossible. Jim Lovell floated toward the panel. What did we lose? Haise quickly checked his instruments. Nothing made sense. One system after another was reporting impossible readings. At first, they believed the instruments themselves had failed. Surely every system couldn't be malfunctioning at once.
Mission Control noticed something strange as well. Telemetry flowing from Apollo 13 suddenly became chaotic. Numbers disappeared. Signals fluctuated. Several controllers frowned. Electrical readings no longer matched expected values. Gene Kranz looked across the room. "Ecom, what's going on?" Swigert stared intently at his monitor. "I've got a main bus undervolt." Another controller interrupted. "I'm seeing strange telemetry too." For several seconds, nobody knew whether the spacecraft had suffered a computer glitch or something far worse. Inside Odyssey, Jack Swigert reached for the microphone. His voice remained remarkably calm. There was no panic. Years of NASA training had taken over. "Houston?" A brief pause. "We've had a problem here." Mission Control immediately requested clarification. Jim Lovell picked up the microphone. "Houston, we've had a problem." Those 5 words would become one of the most famous sentences in human history. But inside the spacecraft, nobody realized history was being made. They were too busy trying to stay alive. Mission Control began asking rapid-fire questions. "What kind of problem? What are your readings? Repeat your voltages." The astronauts answered one system at a time. "Fuel cell number 3, offline. Main bus voltage, falling. Oxygen pressure, dropping rapidly." Then, Lovell looked through one of the side windows. At first, he thought his eyes were playing tricks on him. Tiny white particles drifted past the spacecraft, hundreds of them, thousands, beautiful against the blackness of space, like sparkling snow. But there is no snow in space. His stomach tightened. Those weren't ice crystals. They were something escaping from Apollo 13, something that should never be outside the spacecraft. Lovell spoke quietly. "We're venting something into space." Mission Control froze. "Say again?" "We're venting something into space." Gene Kranz immediately understood the danger. If oxygen was escaping, the spacecraft itself was dying. Back inside Odyssey, the crew quickly searched every possible explanation. Could a valve be stuck open? Could a pipe have ruptured? Could a sensor be lying? Every possibility seemed more comforting than the truth. Then another reading changed. Oxygen tank number 2, 0. It had emptied completely, within minutes. Impossible. Liquid oxygen stored under enormous pressure simply did not disappear without reason. Something catastrophic had happened. The astronauts still didn't know exactly what. Mission Control hoped the second oxygen tank remained healthy. If Tank 1 survived, perhaps the mission could still continue. Then, Tank 1 pressure began falling too, slowly at first, then faster. Every controller inside Mission Control watched the same horrifying graph. There was no computer error, no faulty sensor. The spacecraft was losing oxygen, and oxygen meant much more than breathing. The fuel cells required oxygen to produce electricity. Without electricity, navigation computers would shut down, communications would fail, guidance systems would die, water production would stop, cabin heating would disappear. Every critical system depended upon electrical power. Every electrical system depended upon oxygen. One failure was becoming dozens. Swigert quietly spoke the words nobody wanted to accept. "We're losing fuel cell 1. Seconds later, fuel cell 1 shut down. Fuel cell 2 continued struggling. Voltage continued dropping. Lights inside the spacecraft dimmed slightly. The astronauts watched their home slowly losing life. Mission Control searched desperately for solutions. Controllers opened emergency procedure books. Engineers raced through calculations. Phone lines exploded with activity. Experts who had gone home were urgently called back. Across NASA, people began running. No one spoke about landing on the moon anymore. The mission had changed completely. Jim Lovell remained astonishingly calm. Years later, many people would praise the astronauts for their courage, but courage wasn't what kept them alive during those first minutes. Training did. Every simulation, every checklist, every impossible emergency they had rehearsed. Now, every lesson mattered.
Outside the spacecraft, the leak continued. Invisible oxygen poured endlessly into the vacuum. Every second, another piece of Apollo 13 disappeared forever. And with every passing minute, the chances of bringing 3 Americans safely home grew smaller, far smaller. Mission Control finally reached a conclusion nobody wanted to accept. Apollo 13 was no longer a lunar mission. It had become a fight for survival.
Mission Control had spent nearly a decade solving impossible problems, but nothing in NASA's history had prepared them for this. Not Mercury, not Gemini, not Apollo. Never before had an American spacecraft suffered a catastrophic explosion nearly 200,000 miles from Earth. Inside Mission Control, the atmosphere changed instantly. The casual conversations disappeared. Coffee cups sat untouched. Nobody looked away from their console. Every controller understood the brutal reality. 3 astronauts were running out of oxygen, running out of electricity, running out of time. Flight Director Gene Kranz stood silently for a moment. Then he broke the silence. "Let's work the problem." Those 4 words spread through the room like electricity. Nobody argued. Nobody panicked. Everyone simply began working. Engineers flipped through emergency procedure books. Flight controllers covered walls with calculations. Telephones rang continuously as specialists rushed back to NASA. The mission was no longer about reaching the moon. The mission was bringing 3 men home alive. Inside Odyssey, the astronauts still didn't know exactly what had exploded, but they could clearly see the consequences. More warning lights illuminated the control panel. Fuel cell number 2 failed. Now only 1 remained. Jack Swigert stared at the electrical display. The numbers continued falling. There was no sign of recovery. Jim Lovell quietly looked through the side window again. The stream of white gas was still pouring into space. The leak hadn't slowed. It hadn't stopped. Every second, another part of their survival disappeared forever. Mission Control desperately searched for options. Could the damaged system somehow be repaired? Could electrical power be rerouted? Could oxygen be isolated? One by one, every possibility disappeared. Then came the worst realization of all. Without electricity, the command module, Odyssey, would eventually die. And Odyssey wasn't just another spacecraft. It was the only vehicle capable of bringing the astronauts safely back through Earth's atmosphere. If Odyssey lost all power, the crew would never make it home. The astronauts now faced a terrifying choice: stay inside a dying spacecraft or move into the lunar module. The lunar module, Aquarius, had never been designed for this purpose. It was built to carry 2 astronauts, not 3. It was designed to support life for about 45 hours on the moon, not nearly 4 days in deep space. It wasn't a lifeboat. Yet suddenly, it was the only lifeboat they had. Gene Kranz made the decision: power up the lunar module. The order echoed through Mission Control. Controllers immediately understood its significance. Nobody had ever activated the lunar module this early during a mission. Entire procedures had to be invented on the spot. NASA had trained for many emergencies. This wasn't one of them. Inside Apollo 13, Jim Lovell quickly acknowledged the instruction. The astronauts floated toward Aquarius. Normally, powering up the lunar module followed a careful schedule lasting hours. Now they had minutes. Checklists disappeared. Improvisation took over. Switches flipped rapidly. Circuit breakers clicked into place. Computer systems awakened. Slowly, Aquarius came alive. Lights illuminated the tiny cabin. Life support systems activated. For the first time, the lunar module wasn't preparing to land on the moon. It was preparing to save 3 lives. Meanwhile, Mission Control continued racing against time. Engineers calculated how long Aquarius could support 3 men. The answer was deeply unsettling. Not long enough. Water supplies were limited.
Battery power was limited. Most frightening of all, the amount of breathable oxygen and carbon dioxide removal capability had never been designed for 3 astronauts over such a long journey. Even if they reached Aquarius safely, another problem was already waiting. The moon itself complicated everything. Apollo 13 was still traveling toward it at enormous speed. Simply turning around wasn't possible. There wasn't enough fuel. There wasn't enough time. Instead, NASA would have to use the moon's own gravity. The spacecraft would swing around the far side of the moon, like a stone flying around the end of a sling. Only then could gravity redirect Apollo 13 back toward Earth. The plan sounded almost unbelievable, but orbital mechanics left no alternative. The moon, the destination they could no longer visit, would now become their only path home. Outside the spacecraft, space remained silent, beautiful, cold, unforgiving. The moon continued growing larger through the windows, yet nobody aboard Apollo 13 looked at it with excitement anymore. They looked at it as an obstacle they somehow had to survive. Back on Earth, news of the accident slowly reached television networks. Regular programming was interrupted. Breaking news bulletins appeared. Americans who had barely followed Apollo 13 suddenly rushed toward their televisions. Families gathered together. Schools rolled televisions into classrooms. Factories paused work. People whispered the same question: can they survive? No one knew the answer. Not reporters, not NASA, not even the astronauts themselves. For the first time since the beginning of the space race, the entire world wasn't watching astronauts chase glory. They were watching them fight for their lives. And the hardest part hadn't even begun.
Until that moment, it had been nothing more than a spacecraft designed to carry 2 astronauts from lunar orbit down to the moon's surface. Now, it had become something entirely different. It had become humanity's first lifeboat in space. Jim Lovell floated through the narrow tunnel connecting Odyssey to Aquarius. Behind him came Fred Haise. Jack Swigert remained inside the command module just long enough to begin shutting down systems that normally would never be turned off during a mission. One by one, switches moved to off. Navigation displays went dark. Cabin lights disappeared. Computers shut down. It felt as though the spacecraft itself was dying. Odyssey had carried them safely away from Earth. Now they were being forced to abandon it. Jim Lovell looked around the familiar cabin. Just hours earlier, this had been their home. Now it was becoming an empty shell drifting through space. Nobody knew whether it would ever come back to life. Back inside Mission Control, dozens of engineers surrounded blackboards covered with equations. Slide rules moved constantly. Calculators clicked without pause. Every department searched for answers. One team studied electrical power. Another calculated oxygen consumption. Others analyzed spacecraft temperatures, fuel reserves, communications, and trajectory. No single person could solve the crisis. It would require thousands of minds working together. Gene Kranz quietly walked between the controllers. Despite the growing pressure, his voice never rose. His calmness spread across the room. If the flight director remained composed, everyone else could too. NASA's greatest strength had never been rockets. It had always been people. The astronauts finally settled inside Aquarius. Immediately, a new problem appeared. The lunar module felt incredibly small, because it was. It had been designed for 2 astronauts. Now, 3 grown men would live inside it for nearly 4 days. There was barely enough room to move. No privacy, no comfort. Every wall was covered with equipment. Every inch of space mattered. They floated shoulder to shoulder, careful not to bump important switches. Outside, the temperature in space remained unimaginably cold. Without sunlight, surfaces plunged hundreds of degrees below zero. Without adequate electrical power, Aquarius couldn't provide normal heating. Mission Control issued another painful instruction: turn off everything that isn't absolutely necessary. The astronauts obeyed. Cabin heaters, off. Navigation equipment, off. Interior lighting, reduced to a minimum. Every unnecessary electrical system disappeared. Battery power became priceless, because those batteries would eventually be needed during re-entry. If they wasted electricity now, they might survive space only to die minutes before reaching Earth. Hours passed. The cabin slowly became colder. At first, it was only uncomfortable. Then, the cold became impossible to ignore. Condensation formed on every metal surface. Tiny water droplets floated through the cabin. The astronauts wore extra clothing, but it wasn't enough. Their breath became visible. Every surface they touched felt icy. Soon, the temperature dropped to around 38 degrees Fahrenheit, barely above freezing. Sleeping became almost impossible. Their fingers grew numb. Simple tasks became harder every hour, yet nobody complained. They had larger problems. Mission Control continued searching for ways to conserve every possible resource. Water consumption became the next concern. Normally, each astronaut drank several liters every day. Now, that wasn't possible. Every ounce had to be rationed. Jim Lovell looked at his drinking pouch. The amount inside would barely satisfy normal thirst. Now, it had to last far longer. The astronauts reduced themselves to only a few small sips each day. Soon, their mouths became painfully dry. Their lips cracked. Dehydration slowly began to affect all three men. Fred Haise suffered the most. His body needed more water than he could safely drink. Nobody knew it yet, but dehydration would soon make him seriously ill. Outside the spacecraft, Apollo 13 continued racing toward the moon. Ironically, the explosion had not slowed them down. Gravity kept pulling them forward. The moon grew larger through every window. The astronauts had dreamed of this view for years. Now it only reminded them how far they were from home. Across America, television stations abandoned regular programming. Newspapers rushed special editions to print. NASA held frequent press briefings. Reporters crowded outside Mission Control. The entire story dominated national headlines. Families prayed. Churches opened their doors. Schools paused lessons to discuss the mission. People who had ignored Apollo 13 only hours earlier now couldn't stop watching. The entire world understood something terrifying. If NASA failed, 3 Americans would die farther than Earth than any human beings in history. Inside Mission Control, Flight Dynamics Officer Jerry Bostick studied the spacecraft's path. Something worried him. The explosion had slightly altered Apollo 13's trajectory. If nothing changed, the spacecraft would miss Earth by thousands of miles. Even surviving the explosion wouldn't matter. They would drift endlessly through space. Another maneuver would be required. But firing the engine introduced enormous risks. What if the explosion had damaged it? What if the burn pushed them farther away? What if it caused another failure? Every possible solution carried danger, yet doing nothing guaranteed disaster. Gene Kranz gathered his senior controllers. Nobody pretended to have easy answers. One engineer quietly summarized the situation. "We're making this up as we go along." It wasn't defeat, it was reality. Apollo 13 had entered territory no one had ever experienced before. Every checklist ended here. Everything beyond this point would have to be invented. As darkness surrounded the spacecraft once again, Jim Lovell looked out one of Aquarius's small triangular windows. The moon filled much of his view. It looked close enough to touch. For years, walking there had been his greatest dream. Now he silently accepted something heartbreaking. He would never set foot on its surface. The moon had become nothing more than a giant turning point on the longest journey home imaginable. And before they could even think about reaching Earth, NASA faced another deadly problem. A problem that couldn't be seen, couldn't be heard, couldn't be smelled. But within hours, it threatened to kill all 3 astronauts. Carbon dioxide.
There are many ways to die in space. An explosion, a fire, running out of oxygen, losing pressure, being struck by debris. But one of the deadliest dangers is completely invisible. You cannot see it, you cannot smell it, you cannot taste it, and by the time you realize it's killing you, it may already be too late. That silent killer is carbon dioxide. Every breath a human exhales contains it. On Earth, it disappears into the atmosphere. Inside a spacecraft, it has nowhere to go. Without a system to remove it, carbon dioxide slowly fills the cabin until breathing becomes impossible. Headaches begin, then confusion, then unconsciousness, finally, death. Inside Aquarius, 3 astronauts continued breathing in a spacecraft designed for only 2. Every minute, carbon dioxide levels climbed higher. Mission Control noticed it first. Rows of telemetry data streamed across computer monitors. One controller frowned, then checked again. The numbers were unmistakable. Carbon dioxide was rising fast. Engineers quickly calculated how long the lunar module's air purification system could handle 3 men. The answer stunned everyone. It wouldn't. The lithium hydroxide canisters, the filters that removed carbon dioxide, would become saturated long before the astronauts reached Earth. Even if every other problem was solved, the crew would slowly suffocate. Gene Kranz looked around Mission Control. No one spoke. Everyone understood the urgency. They weren't racing against fuel anymore. They were racing against the air itself. Inside Aquarius, the astronauts still felt relatively normal. Jim Lovell studied another checklist. Fred Haise rubbed his tired eyes. Jack Swigert monitored electrical systems. None of them could see carbon dioxide building around them, but Mission Control could. NASA immediately searched for replacement filters. There was only one problem. The lunar module carried only enough square lithium hydroxide canisters for its original mission. Those filters would soon be exhausted. The command module, Odyssey, still contained plenty of fresh filters, but there was another problem. The filters inside Odyssey were square. The openings inside Aquarius were round. The 2 systems had never been designed to work together. A square cartridge could not fit inside a round hole. One engineer quietly summarized the situation. "We've got to fit a square peg into a round hole." That simple sentence would become almost as famous as the astronauts' call to Houston. Immediately, another team of engineers rushed into action. They gathered every item the astronauts had aboard Apollo 13. Plastic bags, cardboard covers, flight manuals, socks, spacesuit hoses, gray duct tape. Nothing else could be used. If it wasn't already inside the spacecraft, it couldn't help them. On a large table inside Mission Control, engineers dumped identical equipment. Then they began building. Not a spacecraft, not a computer, but an air filter, using nothing more than tape, cardboard, hoses, and plastic. Failure wasn't an option. If their homemade design didn't work, 3 astronauts would die. Hours passed. The room became almost silent. Engineers measured airflow, modified connections, tested seals, tore prototypes apart, started over again and again.
Finally, someone switched on the airflow. The homemade device worked. Carbon dioxide levels dropped exactly as hoped. For a brief moment, the room erupted in applause, but celebration lasted only seconds. Now came the difficult part. The astronauts had to build it themselves, nearly 200,000 miles away, without seeing the engineers, using only spoken instructions. Jim Lovell picked up his headset. "Houston, go ahead." Mission Control began reading the strangest construction project in NASA history. Take the plastic bag, now the cardboard cover, wrap it tightly with duct tape, connect the suit hose. The astronauts carefully followed every instruction. Jack Swigert smiled slightly. It looked ridiculous. The most advanced spacecraft ever built was now depending on something that resembled a homemade science project. Fred Haise wrapped another strip of tape. Jim Lovell secured the final connection. The device looked crude, almost laughable, but appearances meant nothing. Only one thing mattered. Would it work? They connected the filter, waited. Mission Control watched telemetry in complete silence. Carbon dioxide levels stopped rising. Then, slowly, they began falling. Cheers erupted across Mission Control. Engineers stood from their consoles. Some hugged each other. Others simply closed their eyes in relief. The homemade filter had worked. 3 lives had just been saved with cardboard, plastic, and duct tape. But the celebration was brief because Apollo 13 still faced an enormous challenge. The spacecraft was nearing the far side of the moon. Soon, the moon itself would block every radio signal between Apollo 13 and Earth. For nearly an hour, Mission Control would lose all communication. Normally, that blackout was expected, routine, but nothing about Apollo 13 was routine anymore. If another emergency happened while they were behind the moon, NASA could do absolutely nothing. They would simply wait and hope. Jim Lovell floated toward the window. The moon now filled almost the entire view, gray, silent, covered with ancient craters. He had waited years to walk there. Now he was only a few dozen miles away, closer than almost any human in history, yet farther from achieving his dream than ever before. No landing would happen, no flag would be planted, no scientific experiments would begin. Instead, Apollo 13 would become the closest any crew had ever come to the moon without setting foot on it. As the spacecraft disappeared behind the lunar horizon, Earth vanished from view. Radio signals faded. Then, complete silence. For the first time since the explosion, 3 astronauts were completely alone on the far side of the moon, with no way to call for help and no guarantee they would ever see Earth again.
There are many ways to die in space. An explosion, a fire, running out of oxygen, losing pressure, being struck by debris. But one of the deadliest dangers is completely invisible. You cannot see it, you cannot smell it, you cannot taste it, and by the time you realize it's killing you, it may already be too late. That silent killer is carbon dioxide. Every breath a human exhales contains it. On Earth, it disappears into the atmosphere. Inside a spacecraft, it has nowhere to go. Without a system to remove it, carbon dioxide slowly fills the cabin until breathing becomes impossible. Headaches begin, then confusion, then unconsciousness, finally, death. Inside Aquarius, 3 astronauts continued breathing in a spacecraft designed for only 2. Every minute, carbon dioxide levels climbed higher. Mission Control noticed it first. Rows of telemetry data streamed across computer monitors. One controller frowned, then checked again. The numbers were unmistakable. Carbon dioxide was rising fast. Engineers quickly calculated how long the lunar module's air purification system could handle 3 men.
The answer stunned everyone. It wouldn't. The lithium hydroxide canisters, the filters that removed carbon dioxide, would become saturated long before the astronauts reached Earth. Even if every other problem was solved, the crew would slowly suffocate. Gene Kranz looked around Mission Control. No one spoke. Everyone understood the urgency. They weren't racing against fuel anymore. They were racing against the air itself. Inside Aquarius, the astronauts still felt relatively normal. Jim Lovell studied another checklist. Fred Haise rubbed his tired eyes. Jack Swigert monitored electrical systems. None of them could see carbon dioxide building around them, but Mission Control could. NASA immediately searched for replacement filters. There was only one problem. The lunar module carried only enough square lithium hydroxide canisters for its original mission. Those filters would soon be exhausted. The command module, Odyssey, still contained plenty of fresh filters, but there was another problem. The filters inside Odyssey were square. The openings inside Aquarius were round. The two systems had never been designed to work together. A square cartridge could not fit inside a round hole. One engineer quietly summarized the situation. "We've got to fit a square peg into a round hole." That simple sentence would become almost as famous as the astronauts' call to Houston. Immediately, another team of engineers rushed into action. They gathered every item the astronauts had aboard Apollo 13. Plastic bags, cardboard covers, flight manuals, socks, spacesuit hoses, gray duct tape. Nothing else could be used. If it wasn't already inside the spacecraft, it couldn't help them. On a large table inside Mission Control, engineers dumped identical equipment. Then they began building. Not a spacecraft, not a computer, but an air filter, using nothing more than tape, cardboard, hoses, and plastic. Failure wasn't an option. If their homemade design didn't work, 3 astronauts would die. Hours passed. The room became almost silent. Engineers measured airflow, modified connections, tested seals, tore prototypes apart, started over again and again. Finally, someone switched on the airflow. The homemade device worked. Carbon dioxide levels dropped exactly as hoped. For a brief moment, the room erupted in applause, but celebration lasted only seconds. Now came the difficult part. The astronauts had to build it themselves, nearly 200,000 miles away, without seeing the engineers, using only spoken instructions. Jim Lovell picked up his headset. "Houston, go ahead." Mission Control began reading the strangest construction project in NASA history. Take the plastic bag, now the cardboard cover, wrap it tightly with duct tape, connect the suit hose. The astronauts carefully followed every instruction. Jack Swigert smiled slightly. It looked ridiculous. The most advanced spacecraft ever built was now depending on something that resembled a homemade science project. Fred Haise wrapped another strip of tape. Jim Lovell secured the final connection. The device looked crude, almost laughable, but appearances meant nothing. Only one thing mattered. Would it work? They connected the filter, waited. Mission Control watched telemetry in complete silence. Carbon dioxide levels stopped rising. Then, slowly, they began falling. Cheers erupted across Mission Control. Engineers stood from their consoles. Some hugged each other. Others simply closed their eyes in relief. The homemade filter had worked. 3 lives had just been saved with cardboard, plastic, and duct tape. But the celebration was brief, because Apollo 13 still faced an enormous challenge. The spacecraft was nearing the far side of the moon. Soon, the moon itself would block every radio signal between Apollo 13 and Earth. For nearly an hour, Mission Control would lose all communication. Normally, that blackout was expected, routine, but nothing about Apollo 13 was routine anymore. If another emergency happened while they were behind the moon, NASA could do absolutely nothing. They would simply wait and hope. Jim Lovell floated toward the window. The moon now filled almost the entire view, gray, silent, covered with ancient craters. He had waited years to walk there. Now he was only a few dozen miles away, closer than almost any human in history, yet farther from achieving his dream than ever before. No landing would happen, no flag would be planted, no scientific experiments would begin. Instead, Apollo 13 would become the closest any crew had ever come to the moon without setting foot on it. As the spacecraft disappeared behind the lunar horizon, Earth vanished from view. Radio signals faded. Then, complete silence. For the first time since the explosion, 3 astronauts were completely alone on the far side of the moon, with no way to call for help and no guarantee they would ever see Earth again.
As Apollo 13 slowly made its way back toward Earth, the celebration inside Mission Control was brief. Yes, the crew had survived the explosion. Yes, the course correction had worked. Yes, Earth was finally growing larger through the windows. But no one at NASA believed the astronauts were safe, because their greatest challenge was still waiting. The command module, Odyssey, had been without normal electrical power for nearly 4 days. No spacecraft had ever been shut down this way during a lunar mission. It simply wasn't supposed to happen. Normally, Odyssey remained fully powered until splashdown. Every computer, every navigation system, every communication circuit, every critical instrument, always alive, always ready. Now, most of them were dead. And if Odyssey couldn't be brought back to life, the astronauts would never survive re-entry. The lunar module, Aquarius, had saved them in deep space, but it had never been designed to fly through Earth's atmosphere. It had no heat shield. If they stayed inside Aquarius, it would burn to pieces during re-entry. Their only hope was returning to Odyssey, the spacecraft everyone had abandoned days earlier. Inside Mission Control, electrical engineers faced an impossible assignment. They had to create an entirely new startup procedure. Normally, powering up Odyssey required nearly 55 amps electricity. The remaining batteries could safely provide only a fraction of that. If the astronauts used too much power, the batteries would be exhausted before re-entry. If they used too little, the spacecraft wouldn't function. Every switch mattered, every circuit mattered, every single watt mattered. For more than 80 hours, engineers tested procedures inside identical Apollo simulators, again and again and again. Each failure taught them something, each success brought new hope. Finally, they found a sequence that might work. It reduced power consumption to levels no one had ever imagined possible. The procedure contained dozens of carefully timed steps. There was absolutely no room for error. Far above Earth, Jim Lovell received the new checklist. He stared at page after page of handwritten instructions. Nothing about it looked familiar. It had not been part of NASA's training. It had been invented only hours earlier. Jack Swigert smiled nervously. "If this works," he joked quietly, "it'll be one for the history books." No one laughed. The stakes were too high. Slowly, the astronauts floated back into Odyssey. The cabin was freezing. Condensation covered nearly every surface. Tiny droplets of water floated through the air like crystal beads. Electronic equipment glistened with moisture.
The astronauts worried that water might cause electrical short circuits. One spark could destroy everything. Jim Lovell reached toward the first switch. He hesitated, then clicked it on. Nothing. Another switch. A faint light appeared, then another and another. One by one, tiny signs of life returned. It felt as though the spacecraft was waking up from a deep sleep. Mission Control watched every electrical reading with absolute concentration. Battery voltage, holding, current draw, acceptable. Another system came online, still good. Another, still good. The room remained silent. Nobody wanted to celebrate too early. Outside, Earth was no longer just a distant blue star. It had become a recognizable world. White clouds swirled above deep blue oceans. The astronauts could finally distinguish continents. Home. After days trapped inside a frozen spacecraft, it looked more beautiful than ever. Jim Lovell later admitted that he had never appreciated Earth so deeply until he almost lost the chance to see it again. From nearly 250,000 miles away, everything that divided humanity disappeared. No borders, no politics, no conflicts. Only one fragile planet floating alone in an endless universe. But another difficult task remained. The lunar module, their lifeboat, had carried them safely through the worst crisis in NASA's history. Now it had to be abandoned. Jim Lovell looked around Aquarius. This tiny spacecraft had become their home. It had kept them alive, protected them from freezing space, given them one final chance. Leaving it behind felt almost emotional. The astronauts carefully transferred the last essential equipment into Odyssey. Then, one by one, they floated through the tunnel. Jim Lovell was the last to leave. Before closing the hatch, he looked back one final time. Quietly, he whispered, "Thank you, Aquarius." Moments later, the lunar module separated. Through the window, the astronauts watched it slowly drift away into the darkness. The spacecraft that saved their lives disappeared forever. No cheers, no applause, just silence. Now there was only one spacecraft left, Odyssey. Damaged, frozen, barely alive. And ahead, Earth's atmosphere waited. It would be the final test. Apollo spacecraft returning from the moon struck Earth's atmosphere at nearly 25,000 miles per hour. The friction generated temperatures of approximately 5,000 degrees Fahrenheit, hotter than molten lava. Only the heat shield beneath Odyssey could protect the crew. But there was one terrifying question no one could answer. When the oxygen tank exploded, had it also damaged the heat shield? There was no camera to inspect it. No astronaut could perform a spacewalk to check. No sensor could provide the answer. NASA could only hope. If even a small section of the heat shield had cracked, Odyssey would burn apart during re-entry. 3 astronauts would survive everything, only to perish minutes before reaching home. Mission Control had done everything humanly possible. The astronauts had done everything they could. Now their fate rested on a piece of protective material no one had ever seen.
Earth filled the windows of Apollo 13. For the first time in nearly 6 days, home looked close enough to touch. Yet no one inside the spacecraft allowed themselves to celebrate. Not yet. Because reaching Earth was never the hardest part. Surviving the return was. Inside Mission Control, the room had fallen almost completely silent. Hundreds of engineers stared at their computer screens. Some had been awake for nearly 4 straight days. Their eyes were red. Coffee cups covered every desk. No one cared. Months of preparation, years of engineering, and nearly a decade of lunar exploration would all come down to the next few minutes. Gene Kranz looked across the room. Every controller understood the mission. There was nothing more to calculate, nothing more to invent, nothing more to fix. For the first time since the explosion, Apollo 13 was on its own.
High above Earth, Jim Lovell looked around the cabin. The 3 astronauts had lost weight. Their faces looked exhausted. Their clothes were damp from days of freezing condensation. None of them had slept properly. Fred Haise's fever had grown worse. Jack Swigert's hands were cracked from dehydration. Jim Lovell himself had barely eaten. They looked nothing like the confident crew that had launched 6 days earlier. Yet something else had changed. They had become stronger. Not physically, but mentally. They had stared death in the face again and again and refused to surrender. Mission Control gave the final instructions. Prepare for command module separation. One last checklist, one last confirmation. Then, the damaged service module separated from Odyssey. For the first time, the astronauts could finally see what had happened. Jim Lovell floated toward the window. His eyes widened. An entire side of the service module was gone. Not dented, not cracked, gone. Huge pieces of metal had been ripped completely away. Internal wiring hung exposed into space. Panels that should have protected the spacecraft simply no longer existed. For several seconds, no one spoke. The astronauts finally understood how close they had come to dying. If the explosion had occurred only slightly differently, the command module itself might have been destroyed. The lunar module, their lifeboat, would never have had time to save them. Jim Lovell quietly whispered, "My God." Even seasoned NASA engineers were shocked when they saw the television images. The damage was far worse than anyone had imagined. Against all odds, Apollo 13 was still flying. Now, only one separation remained: Aquarius, the lunar module that had kept 3 men alive. Jim Lovell looked toward the small spacecraft one final time. It had never reached the moon. It had never completed the mission it was built for. Yet it accomplished something even greater. It saved 3 human lives. Mission Control gave the command: release Aquarius. Small explosive bolts fired. The lunar module slowly drifted away, silently, gracefully, disappearing into the darkness forever. The astronauts watched until it became nothing more than another object among the stars. None of them imagined that decades later, people around the world would remember Aquarius as one of the greatest spacecraft ever built. Not because it landed on the moon, but because it became humanity's first successful lifeboat in space. Only Odyssey remained. The command module slowly rotated into the correct position. Outside, Earth's atmosphere waited. The spacecraft struck the upper atmosphere at nearly 25,000 miles per hour. Instantly, a wall of plasma surrounded the capsule. Temperatures outside climbed above 5,000 degrees Fahrenheit. The heat shield endured forces almost impossible to imagine. Inside, the astronauts could do nothing, absolutely nothing. They simply waited. Then came the blackout. Every Apollo mission experienced a communications blackout during re-entry. The superheated plasma surrounding the spacecraft blocked all radio signals. Normally, the silence lasted about 3 minutes. Mission Control waited. 1 minute, 2 minutes, 3 minutes. Still nothing. No radio, no signal, no voice. Gene Kranz looked at the mission clock. 3.5 minutes, still silence. Some controllers lowered their heads. 4 minutes, nothing. Someone whispered, "They should have called by now." Nobody answered. The room felt frozen. Millions of people around the world held their breath. Television reporters stopped talking. Families watching from their living rooms silently stared at their screens. 4.5 minutes, still nothing. Had the heat shield failed? Had the spacecraft burned apart? No one knew. 5 minutes, the silence became unbearable. Then, static, just a faint crackle. Every head inside Mission Control lifted at once. Another burst of static, and suddenly, a familiar voice filled the room. "Okay, Joe, this is Odyssey." For a split second, nobody moved.
Then Mission Control exploded. Applause, cheers. Some engineers hugged one another. Others wiped tears from their eyes. Gene Kranz smiled quietly. Against every prediction, against every impossible obstacle, Apollo 13 had survived. Minutes later, 3 bright orange parachutes blossomed above the Pacific Ocean. They opened perfectly. The command module gently descended toward the water. At 1:07 p.m. Eastern Time, April 17, 1970, Odyssey splashed safely into the Pacific Ocean. The mission that many believed would end in tragedy ended in triumph. U.S. Navy recovery helicopters raced toward the capsule. Divers secured flotation equipment. The hatch slowly opened. One by one, Jim Lovell, Fred Haise, and Jack Swigert emerged into the sunlight. Tired, thin, exhausted, but alive. The world erupted in celebration. Church bells rang. Schools applauded. Factories paused work. Across America, millions realized they had witnessed something far greater than a moon mission. They had witnessed the power of teamwork, preparation, leadership, and the unbreakable determination of ordinary people refusing to give up. Apollo 13 never landed on the moon. Officially, NASA classified it as a successful failure. The mission failed to achieve its original goal, but it succeeded in something far more important. It brought every astronaut home alive. The investigation later revealed the cause of the disaster. Years before launch, an oxygen tank had been damaged during manufacturing and testing. Faulty wiring inside the tank created a short circuit when the crew stirred the oxygen. The resulting explosion destroyed one oxygen tank and crippled the spacecraft's power systems. NASA learned painful lessons from Apollo 13. Engineers redesigned critical systems, improved safety procedures, strengthened inspections. Those lessons made future space missions safer for generations to come. Sometimes, history's greatest victories are not measured by reaching a destination. Sometimes, they are measured by refusing to surrender when reaching that destination becomes impossible. Apollo 13 proved that courage is not the absence of fear. It is choosing to keep moving even when every statistic says you should fail. And perhaps that is why this mission continues to inspire the world more than half a century later, because it reminds us that the greatest triumphs are often born from humanity's darkest moments. Now it's your turn. If you had been sitting inside Apollo 13, nearly 200,000 miles from Earth, and Mission Control told you that your chances of survival were almost zero, would you have stayed calm and kept fighting, or would fear have taken over? Share your answer in the comments, because sometimes the greatest battles are not fought on Earth, but inside the human spirit. End of documentary.